everyone. Uh, so I will remind you we will have the exam for this week. Okay, it will be available. Let me see. This will be available from April 22nd to April 25. Okay, so please spend time doing this. You have 3 days to do this, but when you start, you have 2 hours to do this. And for some special case, you have 3 hours to do this. And this exam will have includes 11 questions, just 11 questions. So it's not difficult. And also we have partial credit. If you want to submit to me the explanation, so I will give you some partial credit for this question. So that's it, partial credit for this optional. If you feel you don't need to submit it, that's fine, no problem. Okay, any questions so far about this? Okay, so now we continue to review for the final exams, and we only have today and next Wednesday. After that, we'll finish this course. Okay. So now we finished question 9. I think question 9 about the probabilities. Okay, the definition of probabilities. So today we will move on to the additional rule of probability. So you have the formula here. Okay, so that is the probabilities of the event E or the event F will be equal to the probability of the event E plus the probability of the event F minus the probability of the event E and F. That is the formulas 12 here. Okay. So this is the additional rule for probabilities. Okay. So now we will look at the question 10 to apply this kind of probabilities. Okay. Okay, so this is the question 10. So for story she writing in her high school paper, race surveys are selected at random as they lead the new features, mystery on the Juniper Island. She seems like us each movie years to rate the show using the thumbs up or down and record their age. Okay, so this is the results of her survey. Okay, and we have the people who thumb up, and 18 years old and under is 27 people, and we have the people who thumb up and over 18 years old is 34. Well, this is the information about the survey. Okay, and the question is, what is the probability that once a pre-survey respondents had either given a thumbs up rating or is 18 years old and under? Okay, so it's either they ask the probability of the event E or event F. So now we need to find what is the event E and what is the event F here. Okay, could you tell me what is the event E here and what is the event F here? Okay, Melanie, please.
A thumbs up rating or being 18 years old and under.
Okay, that's the event E is the thumb up rating, right? And event F is 18 years old and under. Thank you. We write down here is the okay, so event E here should be the thumb up, right? And event F here should be the 18 years old and under. we have two events here, right? So the probabilities of the people who are Thomas or 18 years old and under. Okay, we have two events here. The probability of E or F will be equal to probability of E. That means we need to find the probabilities of the people who come up and probability of people who are 18 years old and under, and find the probability of people who have two B's. Okay. And now we need to find what is the probability of E here. Okay, so we look at how many people who come up here. Let's see, we have how many people who come up here. We need to find the number of people. Okay, okay. That is the term of rating, right? Has a term of rating. Okay, respondent. Okay, this is the first one. We need the people in E, right? And number of people in F. So could you tell me what is this one? How many people? How many people? It's come up here. Now we calculate, right?
61.
61. You last term, right?
Yeah, I just used my calculator.
Okay. Exactly. Okay, and we need to find, oh no, sorry, it's not people in F, it's the number of people, the total number of people. Okay, we need to find the total number of people, so we will make the sum of these, and 20 plus 11. So that we can find the probability here. So what is the probability here? So we have, let me write down here. So let's see. So we need to find these probabilities, right? By using the calculator, so we can find this. It is 61 over 91, right? So this is 92. So this is the probability of E, right? And similarly, you can find the probability of F is the number of people in F over the total number of people. So when you tell me how many number of people in F, that means how many people who are 18 years old and under. How many?
47.
47. Okay, 47 exactly. 47 over 92, right? Because the total number is 92. Okay, we have this is the probability of E, this is the probability of F, and we need to find the probability of E and F. That means, okay, probability of who come up and 18 years old and under. Okay, how many? So we need to find how many people who are in E and F. That means come up and this one. It is 27, right? It is 27. 27 over 92. Okay. So now we substitute all the value of PE, PF, PE, and F to this formula. So you can find the probabilities of E or F. Okay, so now I will relate them. PE here is 61 and 2 plus EF here is 47 and this one. And now I get the result here is, okay, so you can calculate this, it should be 0.98804 because they ask you to find, okay, you can enter fraction, okay, you can enter the fraction or you round your answer to 4 decimal places. You can write the answer like this, or you can put the answer as a fraction. No problem. Okay. Any question about this? This is just applying the additional rule for probability. Okay. Thank you. Yeah, look at this. You can look at this. If you have any question, let me know about this. Just apply this formula. Okay. So now we move on to the concept called without replacement and with replacement. Okay, I just replace. What is this? Okay, I will talk to you about the experiment has a with replacement and without replacement. So what is this? For example, I will have the box have some marbles here. Some marbles. I have a box have some marbles, and I will do activity like I will get the marble from the box. Right? I get one marble. Step one, I will get one marble from the box. That is step one. I get one marble from the box. Okay. And after I get one marble from the box, okay, and I will throw it. I don't put it to the box again. I will throw it. Step two, I will throw it outside of the box. Out of the box. So this experiment called the without replacement. That means when I get one marble from the box, I will throw it. I don't put it to the box again. So that's called the experiment without replacement. Otherwise, we call it with replacement. That means this is the without replacement, and with replacement that means when I have the box like this, so I get one marble, something like this. And step two, I will relay it. I will put it back. Okay. When I put it back, so this experiment called is with replacement. Okay, that's the concept about the experiment without replacement and the experiment with replacement. Okay. This either I get one marble and I throw it out of the box. I don't put it to the box again. So that is without replacement. And when I get one marble and I put it back to the box, so that is called with replacement. Okay. Okay. Without replacement. Any questions so far? Any question about this? Now I will erase these. So now we will look at the question. We will look at the question 11. So could you tell me what is okay? These is two cards are rolled without replacement from a standard deck of 52 playing cards. What is the probability of choosing a diamond for the second roll if the first card rolled without replacement was a heart? Okay. So I can just remind you some kind of cards in the card. So we have four cards. Okay, this is the diamond. And we have 13 cards like this, and we have the heart. And the heart we have 13 cards also, right? And we have something like this. I don't know. Something like this is the love. This is 13 cards like this, and we have the thing like this. Okay, maybe like this. I cannot write this, so let's see. Okay, this like this. Okay, something like this. This is black, and this we call spade. And 13 cards like this. We have total is 42 cards. And we have four kind of cards here. We have the diamond, we have the heart, we have love, and we have spade cards. Okay. Each of them have 13. We have 13 kind of For each kind of card, we have 13. Okay. And now we need to find the probabilities of choosing a diamond, right? Choosing a diamond for the second card roll. If the first card roll without placement was a heart. Okay. So what is this? Well, okay. So that is, you can see it's a box, right? Box. They have a 40 cards. Right? Have 40 cards. In the first step, you will get one heart. You will have one heart. Okay, one heart. And now they ask you roll without replacement. Without replacement, that means without replacement. That means you rule it, right? Do it outside, and you don't need. Okay, so suppose you tell me how many remaining cards in the box now. Okay, London.
51.
Yeah, 51. Because this is without arrangement. You put it, you don't put it back. You throw it outside. So it's only 51 cards now. Okay. Thank you. So now we have the total number of cards here is 51. So could you tell me what is the probability that we will get the diamond in the second card roll? Okay, Mackenzie, please.
Is it 13 over 51?
Yeah, exactly, because we have 31, right? We have 31 diamond, and we have remaining card is 41, so the probability is 31. Sorry, 13 over 51. Exactly. Okay, I will give you another example in this kind of problem. Not, okay, so I will write down here. So now I will choose two cards. Do one card. Do one card. Do two cards without placement. That means I will get one card, put it outside, get one card, put it outside. That is the two cards without placement. And I want to find the probabilities. This is other question. This is question practice. Find the probabilities of choosing a heart and then a diamond. Okay. Now I want to the same experiment. That's I choose two cards. I put one card and put it outside and get one card, put it outside. So now I want to find the probability of choosing a heart first, and after that I choose the diamond. Okay. So now we will use the multiplication rule here. This is this formula. Okay. Probability of E and F will be probability E times probability F with the condition E. Okay, in this case, we can use this kind of probability. Okay. I want to find the probability of choosing a heart, and after that choosing a diamond. Okay. So now we will apply this formula. So the probability of this one will be calculated by probability of choosing a heart, right? Times probability of choosing a diamond with the condition of choosing a heart first. Okay. That is the probability. So could you tell me what is the probability of choosing a heart in the first step? We have 50 hearts, right? And now we want to choose a heart. So what is the probability here? Please.
13 over 52.
Okay, exactly. 13 over 52. So now when we choose a house, so we put it outside. So now we have only in the box the 41 cards, right? 41 cards. So now we is the 41, and the number of cards is the diamond is 13. So it's the probability here is 13 over 22 times 13 over 51, 52 times 51. Okay, that is the answer. Any questions so far? So you can use calculator to simplify this answer. Okay, so that is about the probabilities. Okay, probabilities. And now we move on to the permutation and combinations. Okay. What is the permutation and what is the combination? So we have the factorial here. Okay, I will show you. The factorial here is calculated by this calculated by these formulas, right? And factorial will be calculated by n times n minus 1 times n minus 2 times 2 times 1, blah, blah. And this is factorial. This is the formula of factorial. And what is about combination and permutation? This is combination here and permutation here. So what is the meaning of these? What the meaning of combination and what is the meaning of permutation? Okay. So I will remind you what is it. Okay, for example, I have the box, right? We have some kind of marbles, and we have some n marbles, something like this. And now I will choose all marbles. Okay. I choose all marbles from this box, right? Okay, so we have these two kind of if the order is important. That means the bubble here has some kind of number 1, 2, 3, 4, 5, 6. So this will be the order here will be important, right? If the bubble has some kind of number, if the order is important, so we have there are NPR way to do this. That is, we will use the permutation. We will use permutation if the order is important. So we will choose all marble from this box, and the order here is important. So we have there are NPR ways to do this. Okay. If the order is not important, okay, for example, we don't have any number here. So the row of these marbles are the same. Okay, we have the row of marbles are the same. So in this case, the order is not important, right? So in this case, we have there are NCR ways to do it. So be careful. If the order is important, so we will use permutation. If the order is not important, we will use the combinations. Okay, that's the remark here. Be careful. This is the order is not important. This is the order is not important. This is not important. This is important. Be careful when you do the question. Okay, so now we move on to the question 11. No. Question 12. So the newly elected president needs to decide the remaining 5 spots available in the cabinet. He is appointing if there are 11 eligible candidates for these positions where rank matters. How many different ways can the members of the cabinet be appointed? Okay, so the key word here is the where rank matters. The where rank matters, what does it mean? The order important or the order is not important here. Okay, number 2 please. Yeah, it's important, right? Because they say that rank matters, so have the order, right? Okay, so in this case, the order is important, so we will use the permutation, right? We will use the permutation. Okay, so could you tell me how many ways to do this? How many ways can a member of cabinet be appointed in this case? How many ways? You use permutation, right? So could you tell me how many? Maria, please.
38 and 11.
Yeah, it's 11 B5, right? 11 B5. This is permutation. So what is it? So you use the formula here. Your formula here. Okay. 11 B5 will be equal to 11 factorial over 11 minus 5 factorial. Right? So this means that it's 11 factorial over 6 factorial. Right? So you can use calculator to calculate these values. It should be 11 times blah, blah, 6 times 5 times 4 times 3 times 2 times 1 over to 6 times 5 times 4 times 2 times 3 1. So it's so now we only have 11 times 10 times 9 times 8 times 7, right? So the answer should be this value. Okay. That is the way to find using this formula. Sometimes in your calculator it has some function to calculate the permutation and combination. Okay, I will show you how to use you can use put in the like this. You can 11. You put the b here. Okay, maybe have b here in the calculator here. 11p and 5 here. So you can find this 5 and equal, so you can find the result here. It should be like this. You can use calculator to calculate the permutation and combination. If the combination you relate B by C, you can calculate this by using calculator. You don't need to do this. Okay. This calculator can help you to find the permutation and combination. Any questions so far? So now we move on to the question 13. That's about the random variable. Okay. The table discrete probability distribution. Okay. So could you tell me what is determine whether or not the distribution is a degree probability distribution, and select the reason why or why not. Okay, so I will remind you some things about this. So we have the table like this, right? For example, I will type x here, x1, x2, x3, x5, xn, right? Something like this. And p here is probabilities, corresponding probability. This is b1, b2, b3, bn, something like that. And we have two probability here. The first one, the probabilities of I will be from 0 to 1. Okay. Bi here is the probability of x equal xi. And the second one here is the sum of these probabilities. Okay, this is b1 plus bn will be 1. Okay. That is two probabilities of the discrete probability distribution. Okay, we have two properties here. The first one, the probability will from 0 to 1. The second one, all the sum of these probability is 1. Okay. So could you tell me, determine whether or not the distribution here is the discrete probability distribution or not, and through the reason. Okay, Mackenzie, please.
No, because it adds up to more than one.
More than one.
Yeah.
The sum of these.
Yeah.
More than one. Okay. Exactly. Thank you, Mackenzie. Yeah, exactly. Because the probability here is 3.4 plus 3.8 plus 5.8. So it's 3, 6, 6, 5, 11 over 8. Oh no, not 11. So it's let's see, it's 6 over 8, right? Plus 3 over 8 plus 5 over 8. So it's 9, 5, 14 over 8. So it's greater than 1. Okay, it's different 1. So now we choose the answer here is the side here is no, right? Since the sum of probability is not equal to 1. Thank you. This is the final answer. So choose no. We choose no, and we choose because the sum is not equal to 1. Okay, that is about the random variables. And we also have some kind of problem in this section. We need to find the expectation and variance. But it's expected value. Okay, expected value here. I just remind you, expected value here is x here to be calculated by x1 times b1 plus x2 times b2 plus xn times pn. So that is expected value. That is the way to calculate it. We also have in the formula sheet here, I think. Yeah, here's the expected value here. So it is the same formula. So I just put it here for you to easy to understand. Instead of write the summation like this. So but it is the same. You can write like this. Or you can use this formula. It's the same. Any questions so far? Okay, so we finished this chapter 5. Okay, why? So now we move on to question 14 about the normal distribution. In this one, we need to use the table here. The table of normal distribution here. So I also posted on Canvas, so you can use the formula sheet to print the table of distribution here to use. So now, question 14. Okay. We have x here is 45 and mu here is okay. Let me use. Okay, so x here is 85 and mu here is 80.5. Oh no, 80.8. And sigma here is 1.2. So indicate the on the curve where the x value would be. So here is 85 here, right? Not 85, it's 80.8 because this is mu. The mu is the midpoint, right? Separate the area into equal regions, right? So this is mu here. Mu here is 80.8, and we have sigma is 1.2. So this is the distance here is 1.2. And x is 85, so x should be here. That is the way to find the value. Okay, this is 85. Any questions so far? It's not difficult, right? So now we move on to the next example about the knowledge distribution. A software machine outputs a mean of 26, right? 26. So here mean here is 26. Okay. And what is the probability of filling a cup between 22 and 20 and 29? Okay, 26 here, right? They ask you to find the 22 to 29. That means they ask you to find this area, right? 22 to 29. Okay, and standard deviation here too. So how to do this? The first thing, we need to change x value. Okay, the step one, change x value to z value. How to do this? The z value will be x minus mu over sigma. Okay. In this case, we have 22, mu here is 36, right? So z here will be 22 minus 26 over 2, because sigma here is 2. Similarly, this guy here is 29 minus 26 over 2. So you find z here. The first z here would be, let's see, this guy. Okay, this guy here is 22 minus 26 over 2, negative 2, right? Negative 2. And this guy will be 4 minus 6, 9 minus 6, 3 over 2, 1.5. Okay, so we need to find the error from negative 2 to 1.5. Okay, from here, right? So you need to find the area of 1.5 minus the area of negative 2. Right? To find the error of this region, you can find the error of this region minus the error of this region. So use the table to find the area. Would you tell me what is the area here? What is the area here? 1.5. 1.5 here. So this is 0.9332. And then this guy here is negative 2, right? Negative 2. Let's see. Negative 2 is 0, 0. Oh, 228. Okay. And after that, you minus these, and the final answer should be equal to 0.914104. Okay, this is the final answer. That is about normal distribution. Question 16. Find the value of z such that 0, 0, 5 of the area lies on the right of z. What does it mean? So we have this one. Okay? So find the value of z, that's 0, 0, 5 of the area. Z here we don't know, right? Lies to the right. That means this guy here is 0, 0, 5. 0, 0, 5. So now you will look at the table to find it. Look at the table. Not here. 0, 0, 5. So we look at this table because the value is small, right? Okay. we have this value or this value. Okay. Look at these. 0, 0, 5, 0, 0, 5 here. We have two values here. Near 0, 0, 5. Right? Oh, not here. It's 0, 0, 5, not 0, 0, 0, 5. Not here. 0, 0, 5. So it should be here. Let's see. Okay, we have two values here. So which value will we choose? Which value will we choose? We will choose this or this. Easy, but because distance from this value to this is equal. So if we have this case, we will choose the left one. We will choose the left one. Okay? If we have the case like this, because the distance from this value to 0, 0, 5 equal to this value to 0, 0, 5, so we always choose the left one. Okay? We choose the left one. So within the z here, look at this. It's negative 1.6, right? And this guy is 0, 0, 5. So the answer here is negative 1.65. So we look at this. Question?
Wouldn't that be if it was on the left and not the right?
This is a rule. If we have two values, it's the same
Yeah,
distance.
I mean like, because we're trying to find the z value with 0.05 to the right,
Yeah.
would we look at 1 minus 0.05? and
Oh,
then-
yeah, exactly. Sorry. Yeah, you correctly. It's I'm making my mistake here. 0, 0, 5. So this is should be 1 minus 0, 0, 5. Okay. Exactly. Thank you. So it is 1 minus. Thank you, Mackenzie. You are correctly. So this is my mistake. It's 0.95, right? Okay. So don't choose z like this. Don't choose z like this. So we look at 0.95, right? 0.95. So we look at this. 0.95. 0.95. Where is this? Okay, we have two values here, right? Okay, we have two values here. Right? But two values is near here. Okay. So which value we choose? We also choose the left one. 0.9495. So 1.64, right? 64. Okay. Any questions so far about this? So be careful. So this is my mistake when I do. So this is 005 and I need to change to the left one. Okay, not the right. Okay, this is my mistake when I do. Sorry about this. Okay, so now we move on to the next example. Next example. About 17. Okay, Mackenzie. The mean weight of the adult is 66 kilograms with a variance of 144. Okay, this is sample size here. So we need to analyze the assumption here. So we have mean here is 56, variance here 144, and we have n here is sample size. Okay. What they ask you? Now the probability is that the sample mean would differ from the population mean by more than. Okay, this is the keyword. Something by more than. This is the keyword by more than. 0.85 kilogram. This is 56, right? What does it mean? If the keyword is different from the population mean by more than 0.8 kilogram, that means we will find the area of this region and the area of this region. Okay? By more than. If the keyword here is different from by less than, so you will find the middle one. The regions. The middle regions. So this is 65.2 and this is 66.6 with A. So now we will find a z value. Okay. The z value here is different from the, because we have the sample size here. So the z value here is the, okay, I will write down here. The z value here is x minus mu over sigma square root of n. Okay, z here is calculated by this formula. It's minus 66. Sigma here is okay. They don't give you the standard deviation here. So could you tell me how to find the standard deviation if we know the variance? If you know the variance, okay. Lead please.
Take the square root of 1.5.
Yeah, exactly. We take the square root of variance, so we can find the standard deviation. Right? Okay, be careful when doing this. Sometimes we think this is the standard deviation and we put to the answer, but it's not correctly. The variance here is the square root, is the square of the standard deviation. So standard deviation equal to the square root of the variance. Okay, so we have the variance here is 12 over square root of this one. Okay, so you can find z here. So the answer here is a negative 0.74. And this is similar. Z is equal to 66.8 minus 66 over square root of this one. Let me see. Okay, 66.8. So it is 0.74. Okay. So now we will check this. So you can calculate just one region because the region and here are equal. So find the region here. So find negative 0.74. So find this negative 0.74, right? This one and this one. So find the intersection between them. So it's the answer. Okay. And this one should be 0.2296, right? This one is also 0.2296. So you make the sum of these. So the final answer should be 0.592. This is the final answer. Okay. So now the next time we will finish the next Wednesday we will try to finish all the questions in the final one. And one more thing, you should do the sample exam 4 by yourself. Here we have the sample exam 4 here. So do it by yourself for the preparation for the exam 4. It will be similar. It will similar like the exam 4. So do it. And one more thing. So please do the student evaluation of teaching for me. Okay. Just now I just received 3 reports of students. Just 3 students do it. Okay, spend your time doing this. It is very crucial. Okay, it will affect my grade in my teaching. So we do it as soon as possible if you have time. Thank you so much. And any questions so far about this? Any questions so far about the course, something like this? If you have any trouble about the course, you can meet me at my office in this schedule. You can make me send me the email and ask me if you want to make an appointment. And now we will make attendance. Okay, some are not here. Laurel here. Xavier. Andy Bobby not here. Shaylee. Mackenzie here. Hamid not here. Elizabeth not here.
Bennett was here earlier.
Huh?
Bennett was here earlier.
Elizabeth?
He had his appointment, yeah.
Elizabeth here.
Yeah, Bennett.
Bennett here.
Yeah, he was earlier.
This is Max, right? This is Max, not Bennett.
Oh, I kind of saw his hands in the
Bennett, right? It's Bennett or Max. Okay, so Bennett, procedure. Okay, maybe. I forgot it. Up to Elizabeth here, not here. Geometron leaders. Kipling, live here. James not here. Delaney here. Madeline here. Oh, it's my mistake. Delia, Alondra here. Matthew here. Not Maria here. Okay, finish. Thank you. See you on Wednesday. Okay, you Alondra here.
I just have a question. Are we going to turn in my homework late?
Yeah, I see your homework grade. So I
Okay.
also grade it, no problem. Okay, I will grade it, no problem.
Okay.
Just late a few hours or few days.
It was like 2 days.
Okay.
I just forgot to submit it. But I turned it in on Sunday.
Okay, so no problem. I don't.
Okay, thank you.